Hello and welcome to today's webinar. My name is Emily Owen and I'm an LS-DYNA support engineer at Arup. Today we'll be covering spot welding and connections in Oasys PRIMER. Now, Oasys PRIMER and its connection tool has great functionality to help create and manage connections in your model. This includes spot welds, adhesive and bolts, but today in this webinar we'll just be focusing on spot weld connections. So we're going to be looking at how you create, modify and check spot weld connections in Primer. So looking at the creation options, including the use of auto weld. It's an automatic generation of connections. We'll cover spot weld files, so writing and reading files with information associated to the connection entities. We'll take a look at the connections table. Connections table is where you can manage and view information associated to all the connections within your model. We'll briefly touch on scripting and some options to help manage the creation of connection entities in your model. And we'll look at remeshing. So predominantly spot welds are mesh independent and we use tied contacts to join panels. But there is also a remeshing option within the Primer connection tool. So connections such as spot welds and bolts are defined in LS-DYNA simulations by a series of different elements, constraints and contacts, and that's dependent upon the connection type you're trying to simulate. So setting them up can be a timely and complex process, especially if, for example, you have a body in white which may contain over 1,000 spot welds. It's no easy feat to set them up. But the Primer connection tool allows easy creation and management of various connections. So they allow you as the user to modify and remake multiple connections in one go. You can read various file types and create connections automatically. So this may be if you have an IGES file or a previous generated Spotweld file from an earlier model, for example. You could read that into your model to generate the connections. You can check that any mesh independent connections are attached via tied contacts. So you have a kind of the primer check, and the connection tool itself has the functionality to check any of the connections. And you can use scripting to create and modify connections in more complex ways. So you may have kind of in-house methods, or you have properties of connections to suit dependent the number of panels that you join or the grade of panels. So that will make it easier for the user. Now within Primer there are 4 main connection types. One of them is spot welds, so which will be the basis of today's webinar. And these are beam or solid elements that connect shell parts, and they're usually connected via a tied contact. So they're mesh independent. You create the FE entities in isolation, and then you need to generate a contact to basically stick the panels together. And we'll cover how you'd use the connection tool to do this today. Another type is bolts. So these are rigid types. You might have nodal rigid bodies or constrained rigid bodies to connect joining shell parts together. So these can include kind of beams, or you may use joint methods dependent upon your simulation method. Then there are adhesives. So if you're kind of connecting 2 points with an adhesive line, you can use the connection tool to generate lengths or patches of solid elements connecting the 2 panels. And again, these are connected via a tied contact to generate the actual connection within LS-DYNA. And then you have spot weld lines. So these are similar in configuration to normal spot welds. The difference being that these are groups of spot weld lines, so you can easily do things like modify the pitch, and they can also be linked to a free edge. So for example, if your geometry isn't yet frozen and may be subject to change, if it does, then Primer will be able to update the spot weld line to follow the geometry and avoid you having to individually update the different connections of the spot weld. Now to create a connection in Primer, you go to the Tools section and there you find Connection. This will bring up the Connections panel, and then you can select Create to generate the various connection options. So the first step is to tell Primer which panels you want to connect. So you can do this by either selecting individual elements and parts, or you could select all in the model or those visible. And then the second step is to select the connection type you wish to create. So here you can see the different options available in Primer. You have spot weld, bolt, adhesive, and spot weld lines. Once you've selected these, this will then activate the next button, which you can click to begin creating the connection. Okay, so let me just jump to a demonstration of this. So here I've got a model of a body in white, and there's currently no connections in this model at all. So we're going to use the Primer Connection tool, and this can be found in the Primer interface on the top right hand side in the Tools section. You've got Connection, and then this brings up the Connections panel where you can create connections. So the first step, as mentioned, is to select the elements or parts you wish to connect. So I could select individual elements or parts, but for the purpose of this example, I'm just going to select all those within the model. And then I could select the connection type I wish to create. So we have the 4 options earlier mentioned: spot weld, bolts, adhesives, and spot weld lines. So we'll stick with spot welds and select next. Then this brings up the Make Connections panel. So this is where you specify all the attributes associated with the spot welds you want to create. So there's 3 main inputs to this. The first here is the spot weld element type. So you can see this is a beam. If I drop this down, you have different options. You've got the beam, you can create a hexa, so a single solid element, 4 hexa, 8 hexa, etc. The second input is the part ID for which all the spot welds you create will live. So here you can see this is auto-populated with the part ID already. And the reason for that is that Primer looks through all the parts in the model, and it will identify any that it feels are suitable for the application of the spot welds you're trying to create. So if I edit this, this section ID here is a beam of L49, so a spot weld beam, and the material ID you can see is MAT 100, so spot weld material. So Primer's automatically pre-populated that. If, for example, you didn't have the part already available in the model, then you could use a drop down and create a part for the element itself. Then you also have the spot weld diameter. Here you can see it's greyed out, and that's because we're using a beam. And for a beam, the diameter of the spot weld is defined in the section ID card. But when we do look at a hexa element, you'll see that this becomes active, and you can modify excuse me, the diameter of the spot weld itself. And then down in the bottom here, you have this creation method. So at a basic level, you can select input X, Y, and Z coordinates. So if you know the actual coordinate locations, you can input those here. And then you have this option to pick screen point, and that basically does what it says on the tin. So I can select a location. I've just zoomed in on the B pillar here for demonstration. If I pick a point between those 3 panels, you can see that it's created this green blob. If I zoom in further, here you can see a beam element, well, there's 2 between the 3 panels, have been created when I selected that point. If I select here, for example, you can see when I pick, it generates a screen output of the beams it's created. And you can just select along at different points you wanted to create individual spot welds. Alternative methods include picking a single node, or you could pick all nodes in an individual set. Another useful creation method I find is line of welds. So if I select this and then pick specific points along a line at which I want to create some spot welds, you can see here that in the attributes panel, another option has come up to help define the spot welds you want to create. So you can either input a certain number of welds along the line, or you could specify a weld pitch. So I'm just going to use number here. If, for example, I select 6 and then I sketch the weld positions, you can see it's showing me where it's going to create those welds. When you're happy with that, if if you select apply, then it will generate them at equidistant locations along that line. That's beams. If you wanted to create a hexa element spot weld, if I select this, you can see it's automatically updated part ID to contain the solid spot weld elements. And now that the spot weld spot diameter is active, so if I select a point, switch back to pick screen point here, you can see that it has automatically created a solid element in the location of the spot weld. If I wanted to modify the diameter, example, and change that and then select, you can see it modifies the element size accordingly. So that's just a single hexa. You could create 4 hexa elements or 8 hexa, dependent upon your needs. So that is the creation of individual spot welds. So here it's created just the FE elements themselves. But if, for example, in this model here, to create the entities at each individual location throughout a body in white, just using individual picks would be quite a tiresome exercise. It would be quite time consuming. So within Primer, there's also this auto weld option. When I select this, you can see it brings up another option panel, view input parameters. Now the auto weld option is basically an option and a useful tool when you have no connection information available. So you may be kind of in a design phase and you don't know explicitly where the location of spot welds are, but you could have perhaps design guidelines at where they should sit throughout a body in white. So you could use this auto weld option. Now you can input different parameters. So the minimum run length would be the minimum length of a flange that it would look for. And beyond this, it would then input spot welds. You can define the pitch, the spot welds, and any weld edge distance. And what Primer will do is it will find the free edges within the model and then look along those to check against the parameters and any preferences you have defined, and will generate spot welds at locations it deems appropriate. So here I've got a minimum run length of 50, and I'm just going to keep the pitch at 40 for the example. And if I zoom out and click apply, hopefully you saw then that it highlighted all the free edges of the vehicle in white, and it is now going about each of those free edges and looking up and down, identifying if it meets the minimum run length that you've defined within your parameter, and then is generating, in this instance I kept it as a hexa FE element in each of those locations, and this will just take a few minutes as it runs through. Okay, so now this is completed, you can see it's very quickly gone through the body in white and generated spot welds at all the locations that meet the inputs. So the auto weld option is just a very quick and easy way to produce spot weld connections en masse, perhaps especially when you don't know explicitly the locations in your model. It isn't foolproof. There may be specific locations, perhaps where the parts are too far apart, for example, and it won't create them in that location. So you may have to do a little bit of checking, but on the whole, it will generate them en masse throughout the model. There are other creation methods as well. It's kind of use and needs, dependent upon what type of connection environment you're setting up. So when you finish creating your connections and you've defined all your attributes, if you click dismiss. Now when you dismiss your make connections panel, you will always get this kind of warning message to let you know that the connections are missing from contact definition. So the spot welds we've created are mesh independent in order to basically make them have the stick in effect of a contact connection. You need to define a tied contact, and this is just a reminder that at the moment you've just generated the actual FE, but you need to create a contact, and I'll cover that shortly. You'll also notice that when we dismissed, the blobs of the connections went from green to orange, and Primer will check. This is to suggest that Primer's checked the connection, and at the moment it's not realised. So the connection is requiring the contact, and then later when we come onto this and actually create that, these will change colour. These actual blobs themselves are in all the locations of the contact entities that have been created. So whenever you create a connection within Primer, then it will create this graphical display of where that connection is within the model. So if I go to my entities, here you can see connection entity is switched on and it's drawn. I'll cover a little bit more about explicitly what a connection entity is later. But if you want to kind of switch this off whilst you're using your model, you can deselect that and then update. If I then zoom in on a location, the connection FE is still there, it's still been generated, but just the actual connection entity information itself is switched off. So once you've created the FE entities for your connection, you then need to create the contact to basically stick the panels together. And you can do this from the connections panel itself. You have the contact tab. And if I select this, what Primer will do, it will check on the status of the Spotweld connections and any connectivity between them. So it will look to see if there's already a contact defined and if a connection is realised. Here you can see it's checked and there are 2050 connections that do not tie. So you then have the option to create a connection contact, and what Primer will do is, dependent upon the element type, it will create one of two contact definitions. So if you've created beam spot welds, it will create a star contact spot weld, and if you have solid spot welds defined, then it will create a star contact tied nodes to surface. So if I select create contact, connection contact, is identifying you that I have both solids and beams for contact, the two types of contact that it's going to create, and then also gives you alternatives. So there are different methods you could use. You could just create one of the contacts, or you could sketch the event beam. So in this example, I'm just going to create two contacts, so it gives you the option. And then it will give you the information that it's created. So you saw them go from orange to green to let me know that the connection has been realised. It's created one contact of star contact tied nose to surface for the solids and one for the beams. And then it also notes this flag that it's set to 1 to back up penalty contact. So basically, as these are constraint-based contacts, this could potentially cause any issues if there were connections between rigid parts in the model. And so what Primer's automatically done is set this flag to do a parallel-based contact if there's any rigid constraint clash in the model. So you don't have to set that yourself, it's already automatically done that. Click OK. Now you can see these are green to represent the fact that their connections are good, basically. Switching back to the presentation. This just covers what I've just been through in the demonstration. So the creation of a contact once you've created the connection FE, and that Primer will create two contacts dependent upon the element type. So we have a star contact tied nose to surface for solid, or a star contact spot weld for beams. Now once you've generated any connections in your model, the user can save that information to a file. It's under the right panel within the connections menu, and when you select this, it brings up a panel where you can select the type of connections you wish to write out. So you could write out all the connections in your model. You may just wish to write specifically by layer panels or spot welds or adhesives. And you can also select the format in which you wish to write the file to. So there are two main file types for spot welds. One is a spot weld file, and this is a simple CSV format in which there is one line of data per weld. This contains the coordinates of each spot weld and the panels to which it is connected. And then you have an XML connection file. This is a more complete file format in the sense that it contains more information on the connection themselves, so whether the welds are beams or hexes, for example. And this is a recommended format to avoid losing any information, so avoid you having to recreate specific inputs at a later point in time. But of course, there are other formats available, and it's really dependent upon your needs to which you may choose to write to. As well as write, you can also read connection files. So the same spot welds may have been created in an earlier model or earlier generation of your model, or it could be from another format. For example, if you have CAD data in CATIA format, you could choose to read that in. There are multiple file formats, and depending upon the file format you select, will change the attributes that you're required to input. So if I just switch to an example now. So here we have the same body in white as we used earlier, but there are no connections in this model. They've been previously written out into a data file, and we're going to read them back in. So if I go to connection and read, then it brings up this panel where I can select the file format I wish to read in. Depending upon the actual file format you select will change the attributes associated to it. So if I switch from an XML connection file to Spotweld, you can see that I now have to input the type of element. So the Spotweld file only contains the coordinates and the layers of the parts with which it connects. So if I wanted to, I could change this from a hexa element type to create a beam element, for example, and define the part within which they should be stored. To open the earlier file and click apply, and it will bring up a preview of the information stored within that file, so the coordinates of the locations of the spot welds and any parts with which it should connect. So if I just bring this out of the way and click apply, you can see that Primer has gone through and generated a connection FE at each of those locations stored in that data file. This is just a warning that it's created the FE, but you would still need to create the contact to realise the connection. Then clicking continue brings us to the connection table. The connections table easily allows you to view and modify the connections in your model. So you can choose to view all the connections or a subset of those, and here you can see that Primer has automatically populated the connections table with the connections that it was unable to create when I've just read in that data file. It shows you things like the connection ID, the type of connection. So here we have spot welds and a subtype. So if they're beams or solids, for example. Information if there's any error. So you can hover and it'll show you a little bit more information and further details. The part ID that the connections are associated to. And here we can view the part ID of the individual layers between the connections themselves. So this is just some of the information, but you could also view more or edit what you can see. So here we have a view tab in the top left hand corner. If I select this, you can see a whole host of the information associated to the connections that you could choose to be visible in the table. So you can toggle these on and off, and it will bring in any information you select. So I toggled on diameter, it's updated that. I could switch off the coordinates. I could bring in XYZ coordinate information. You can view things such as layers or parts. You can change the information if there's any remesh, and allows you to manipulate any information that you can see for each of the connections. As well as kind of viewing information, you can also use it to modify and manipulate the connections themselves. So if I right click when I'm over a particular column, you can see here that it brings up a list of actions that you could perform. So you could update and remake, which I'll cover shortly. You can sketch connections, you could sketch the FE, you could show any connection entities and layered panels and delete the connections. And then also you can see that it says change type. So whilst I'm over the spot weld, I could perform the action to change the type from spot weld to a bolt, for example. And depending upon the column that you're hovering over at the time will change the action that you can perform in that part. So it here has the similar ones to the original in Spotweld, but then you can change the part ID. If I'm over a layer, I could change layer 1, for example, here by selecting part ID or by changing what I view. You could also perform global actions. So at the top here we have the action, and if I bring this up, it's a drop down of all the actions that can be performed in the model. You can choose to perform that by selecting apply here on the left hand side. You could do it to all connections in the connections table, or just a selection of those you may have highlighted. You could also use a connections table, not just for spot welders we've got here, but for if you have bolts or adhesives or any type of connection in the model. By toggling these on and off would bring that information to be visible within the table at the time. Switch them on and off. So using this to modify, I can see here that it's been enabled to recreate certain connections from the connection file. If I highlight these top 5 and right click, I'm going to show the connections and the layer panels. This is the connection entities. When I do that, you can see it brings in the connections that it's tried to create. They're highlighted in red here because they've been unable to be made. And also the layers, the parts of the layers that the connection is created between. So here we have the left hand A-pillar, and it's tried to recreate the connection between the right hand A-pillar. So obviously that would be unable to be made. Now what you can do is use the connection table to update this connection to be realized with the correct part IDs. So in this, layer 1 is incorrect. This is the right hand A-pillar. By right clicking over layer 1 column, I can change this layer 1 and I can select part ID, which will bring up a list of all the parts in the model. So here I actually want the left pillar, A-pillar, so selecting that. You can see that it's updated now the information in the connections table and changed layer 1 to reflect the change in the part ID I've just selected. But this is now highlighted in red. And the reason for this is that the update has been made within the connections table itself, but we're yet to update and remake it to reflect that change in the actual model. So when this is red, it means the change has been made. You need to update and remake. So I could perform that action here. It's already set to update and remake, so that will update that information and will remake the connection. So I could choose a selected, or I could right click over any column and select update and remake. Doing that, you can see it has now changed layer 1 to the new part ID. It's changed to black to say that it's checked and updated in the model. And you can see here that the connections are now orange to reflect the change that they've been made. But as of yet, we still need to create the contact. If I want to just double check that, I can right click and show connections and layer panels. Then that will update what I can visibly see in the interface to reflect the change of the panels and that the connections have been made. So that's just a selection of some of the actions that you can perform. Obviously, it's dependent upon your user needs, but it is an easy way to modify or to simply view any connection information or connection details. You can pull this table up at any time. If I bring the model just back into view, the table can be accessed from the connections menu. You have an actual table menu. Selecting this, you can select what connections you want to show in the table when you create it. You could use all connections, could view all connections in the model. Obviously, if there is a lot of connections, then that would be quite a significant amount of information. You could view by layer panels, by attached panels, or if you just wanted specifically a connection type, so spot welds or adhesives. Selecting these, if I went by attached panel, selected the mid rail here and clicked apply. Then it brings up just the spot welds for those attached panels themselves. So that's the connection table. If I now switch back to the presentation, this is showing what I've just covered, a little bit more information on the connection table, the different menus that you can access when you're within the table itself. Other uses of the connection table are a little bit of what I've just demonstrated, in the sense that it can be used to check or modify a subset of spot welds. So, for example, you don't want to necessarily open the connections table with all connections in the model. It might be, especially if you have, say, a body on white like this, for example, where there may be 1,000 connections in the part, but you're just interested in a specific one in particular. And you could isolate that part. So in the selector panel, when you've gone onto table, as I just did, you could go by attached panels, pick a panel in the screen area and click apply. And then Primer will put only those welds connected to the selected panel in the table. So rather than bringing in all connections, it just has those associated. And if you set the action to show connections and panels, selecting all the welds in the table and pressing apply, you could show if there were any missing welds. You could check for any missing welds in the model, and it would highlight just those in particular. As I said, if you use the right click whilst you're hovering over a particular column, it changes the action that you can perform. So you can also update the type of spot weld, as I showed, from a beam to a solid if you wished. And you can also do other things, such as change how you're describing particular layers. So at the moment, default was part IDs, so the parts connected between the layers, but you may wish to use part names or perhaps CAD names if you've imported them through the bill of materials. If you have perhaps star part composite, and the way in which you want to describe the layers is different, then the table will permit you to describe the layers in different ways. So that would be right clicking over the layer panel, which would bring up this menu, and then you could click change to at the bottom, and this would bring up the options for how you can better define the layer in your model. Now, there are various tools in Primer that are provided to check spot welds. So one in particular here, actually within the connections panel itself, is find connected. And this means really just show the welds and panels. So it's a visual check for any missing welds in a particular area. So it brings up a panel of how you can choose to find connected. So if you chose welds, bolts, adhesive from attached panels, then you can select a particular part from a list and click apply. And then Primer will show all the welds and panels connected to the selected panel. So it could be a check if you want to see for any missing connections that may be there and to check connectivity. You could also obviously do a model check. So in Primer, if you model checked, it would look for any tied and untied nodes. And this would be kind of a detailed way of checking individual connectivity. This find connected is more of a visual check. You can also use find unconnected, and Primer will display any parts that are not connected by at least one spot weld in the model. So if you want to check for any perhaps rogue parts that should be connected and aren't, this will be a quick way to visually bring them up onto the screen. And so now I'm going to cover a little bit on connection entities, which you will have heard me mention throughout the presentation. So each spot weld and the corresponding FE has a corresponding connection entity associated to it, which stores the instructions for making the connection. So we've seen we generate an FE, so this may be a beam or a hexa or a 4-hexa finite element. And then basically a connection entity sits on top of this. So the information and is created automatically on top of it. And this will store information such as the coordinates of the connection, the type of the connection, any kind of nodes or solid entities associated. And this method has several advantages. So any failed welds are retained in the model and can be fixed at any time. So you saw from reading in the data file, although it didn't recreate the connection, it saved that connection entity, which I could then check and modify at a later point and update to recreate the connection without having to go in and check and identify, or just recreate the connection without notes there. If you create from a spotweld file, the original XYZ coordinates are retained, and it is easy to change the welds. So you could change from a beam to a solid, for example. And the connection entity isn't just associated to spot welds, other connection types are possible. So for bolts and adhesives, similar information is stored. And for those of you who are familiar with the keyword, then this connection entity information is written after the star end in the keyword file. So it's specifically associated to primer, and it will read that information in. It sits outside of the LS-DYNA keyword deck of the model. And here you can see an example of this. So you have the star connection start of one spot weld, has the coordinates points of the connection, diameter if it's solid, the part that it's associated to. So there's information on the layer of the part IDs and the connection entity. So here we can see it's a solid with an ID value and the associated nodes, and then the end. So they're referenced so that Primer knows which to delete if a connection is deleted or remade. And if you were to read a model in that contains spot welds, FE, but not connection entities, so if the spot welds were not made by Primer, then when you launch the connection tool, Primer will automatically look through the model to identify any kind of spot weld FE, and then will automatically create associated connection information, so connection entities associated to this. So even if before you made even if you hadn't used Primer to set up your connections previously, Primer will create this information for you, which makes it easier to manipulate, and you can then use the functionality such as the connection tool, connection table. The disadvantage of having connection entities is that confusion could arise if, for example, the connection entities become separated from their associated FE. So if, for example, it's split across an include files and only one of the include files was read in, that may be that the actual solid spot weld is in one include, but the connection entities information is stored in another. But by default, Primer creates new connection data and associated FE entities in the current layer. So there are ways within Primer which you can still manage this, and there are options in the connections table to manage include file locations of connection data should this happen. Excuse me, so it's just to be mindful of that. Moving on to spot weld lines. So these are an extension to individual spot welds. And basically here, when you create a spot weld line, although you will create multiple spot welds, there will only be one primer connection entity associated to the suite of spot welds within that line. So it's created in the same connections panel under spot weld lines. It's different to the line method of picking. It is in a particular connection type. And it brings up a similar panel to create spot welds where you can define if it's a beam and the part ID. But this time it changes the creation method. So you could define manually a line and select the inline about the points in the model. You could choose free edge, so it will look through the model and associate a free edge to create the spot welds about. or a specific geometry line within the model. And the advantage to this is that when you create the line, you can define the pitch about which the spot welds are created, and then these can be easily changed at a later point. In addition, the lines can be locked to a free edge, and by that I mean here. So if I demonstrate in these images, here you can see a line of spot welds has been created across this free edge. We've defined a 5mm edge offset and a 20mm pitch. And if we lock this to the free edge, that means that if your geometry is still subject to change, such that the mesh does change at a later point in time, then the connections can be remade to follow the path of the new free edge. So that connection entity will store the information associated to these spot welds and the free edge, and then they can be easily remade as opposed to having to individually update each spot weld across that free edge location. And so this is a different connection type. Briefly touching on scripting now. So Primer has an embedded JavaScript scripting capability that gives you access to and the ability to modify or create model data, as well as giving you access to the Primer functionality. So you could use scripting to perhaps read or write any connection information in any text format. You could create connections from information in files read. You could modify connections according to company-specific rules or modelling methods. So you may have set methods for perhaps material properties, depending to the number of panels that you join. Grade or thickness of panels, etc. may change the connection type, the diameter of a spot weld, for example, and you could use JavaScripting to kind of automatically process this information to save you having to each time having to manually create and update them yourself. So finally, covering spot weld remeshing. Now up to this point, when we've been discussing spot welds, they've been mesh independent, such that we've had to create a star contact to tie the connections themselves to the panels about them. But within Primer, there's now the functionality to remesh. So when we create spot welds, the mesh around them can be remeshed, where you can create rings of elements to represent a heat affected zone in your model. So we're spot welding. In this panel, it's the remesh option underneath the Create Spot Welds panel, which will then bring up another menu where you can choose the diameter you wish to remesh. So you define your spot weld diameter, and this is the diameter about that to remesh. The number of rings about your spot weld, and dependent upon the type of spot weld you'll use, the number of elements and rings will be automatically processed. And then when you've selected the number of rings, here you can define the diameter of each ring, and you can apply a specific part ID to that associated ring. So in a heat affected zone, when you may have varying properties of material about the spot weld itself, you can now automatically add those rings to specific parts and the associated perhaps material ID. If I now just show you this. So here I've just got a very simple model. It's just two shell panels, and I'm going to demonstrate the remesh function in the connections tool. So connections create all. Now when I generally create a hexa element, if I just select, just need to select the part first, so that demonstrates that if the no part ID is selected, you won't be able to create the spot weld. But if I, in the normal form for a mesh independent connection, just select a location, you can see it creates the FE and it's created the 4 hexa element. Now when I select remesh, I can choose the options, and then this will bring up the additional options associated to remeshing. So the moment I've got a spot weld of 5mm, I may want to update the remesh area about that spot weld to 20mm. as an example. And I am going to choose 3 rings about it. So it's going to generate 3 rings of meshes, 3 rings of shell elements around the spot weld itself. Now you need to input the diameter of each of those. So I'll go, for example, 8, 12, and 15. Now I could for this just select. So if I now pick a point, you can see that when I selected that point on the screen, rather than just creating the FE entity, it's now created the FE entity itself, as well as generated and remeshed the surface around it. And that is on both sides of the panel. You can see here, it's updated the mesh. So this connection is now mesh dependent, and it's meshed into the surrounding layers. Now, if you have particular has information, so you may know the material properties in the heat affected zone about your spot weld, when you are in your spot weld remeshing options panel, you can assign part IDs to each one of those rings individually, which may be associated with the material in that part ID. So here, for example, I can select perhaps one part ID, so the same as the spot weld itself, and then further out select the different part IDs for the rings. So now when I select a point to create my spot weld, you can see that it's automatically remeshed in those areas, but now the individual rings about the spot weld that you've defined have been assigned to the part IDs we dictated in the remesh options panel. And it's automatically done that for you. You don't have to go in and update any of the elements or assign them specifically to the part ID. Primer will automatically do that for you. As I select through, you can see it updates it. You could modify this. You could change the number of rings that you have associated. You could also change the type. So if I go back to a hexa part ID, you can now see that it's going to create 4 elements about the ring. I'll keep the same formulations in the ring, select, and it will remesh about that area. So if I just switch back to the presentation, you can see here a demonstration of what I've just shown, that you can remesh for different spot weld types. It's also applicable to beams. You can just choose to remesh in a local area with the rings, up to a various number of rings that you want. And you can use this to model heat affected zones quite easily by assigning part IDs to the ring mesh about the spot weld itself. Now, alternatively, you could use a connection rule to create the spot weld remesh. So this is a special JavaScript, and the script is passed the number of layers, the number of rings and diameter of each ring, the part ID, the material ID, and the thickness for each layer, and the spot weld part ID. So the information it is fed to the remesh, and using these input parameters, the users can then set the part ID and diameter for each ring on each layer. And if a simple example here would be to change the part ID and diameter for each ring on each layer for a hexa spot weld. So you may want to update the layer information based on perhaps a change of parameters or variables, and you could use this rule to automatically update that for you and speed up your processing depending upon the methods you may have in-house. And finally, remeshing parameters such as the diameter and part ID of each region can also be set from the connections table. So I showed you earlier the option in the view panel to activate the remesh columns. And here you could show if a connection has been remeshed, and any associated data, so the remesh diameter and total, and if there are any rings about this, the diameter of those individual rings themselves. And likewise, you could manipulate this using the table to modify any connections. This brings us to the end of today's webinar. So in summary of what we've covered, you can use Primer Connection tool to easily make individual or multiple spot weld connections. Spot welds can be easily modified and updated via the connections table. Users can write and read spot weld data from files of various formats. It's JavaScript capable, and there's also remesh functionality to create has welds. So the connections tool can also create and manage other connection types, such as bolts and adhesives, which we haven't covered today in any detail, but we hope to do so in a future webinar. In the meantime, if you want more information on anything we've covered or other Oasys information, then you can refer to the Primer manual, where you'll find information on the tools that I've discussed today. You could visit our website, where you can gain access to training and webinar, as well as a list of any upcoming training or webinars. And you can also sign up to our newsletter, where you receive regular updates on the Oasys software suite. Or you could visit our YouTube channel, where you'll find a host of various videos from top tips to past webinars. As well as that, you can also contact your local Oasys distributor. For those based in the UK, that's dyna.support@arup.com if you have any questions on anything you've seen today or anything else related to the Oasys LS-DYNA environment. So this concludes our webinar. Thank you very much for listening to the Oasys Primer Spot Welding and Connections, and hopefully you find this useful. I am now on the chat, so if you do have any questions, please feel free to drop them in. Otherwise, wish you a good day. Thank you for listening.